Layers of Protection in the Gut by Dave Mayo. There are multiple layers of protection in the gut. There are physical layers, chemical, mechanical, and microbial. Therefore, having problems with intestinal permeability, also called leaky gut, isn't a single problem. There are multiple problems going on at once. Understanding the basics is helpful. That way, if you're trying to build a better gut, a healthier gut, you know what your targets are to improve. We're going to begin by taking a more macro view, although that is relative because you still need a microscope to see it. We'll start at the top of the page in the gut lumen. At the interface of the gut lumen, which is the center of the intestinal tube that food shoots through, and the first mucus layer, the more loose mucus layer, but it is thicker, we have our microbiome and the microbes that make it up. This functions as a microbial barrier to prevent pathogenic bacteria from getting a hold in our gut. So the more beneficial microbes we have, the less space we have for pathogenic bacteria to cause problems. So in this outer mucus layer, which is only present in the colon, it's not present in the small intestine, we have it's a thicker in width. However, it's very, very loose in that it's not dense. So when we eat, this mucus layer kind of moves along our intestinal barrier, and the microbes within it go as well. We also have different types of antimicrobial peptides, which we'll discuss in a moment, sitting in this layer. And this is a physical barrier to help prevent bad bacteria from causing problems. Next, we have a thinner layer, but it is more dense and attached to, here we're in the colonocytes. This layer does not exist in the small intestine where the enterocytes are. And this is to prevent an even more impenetrable physical mucus barrier between our cells that make up our large intestine and the bacteria from coming into contact with it. This barrier is really important, and it is very, very few bacteria that actually make it into here with a healthy gut. Moving along, we have the epithelium, which is the cells that make up our either our small intestine or large intestine, depending where we are. Here we have the cells that make these different physical and chemical barriers. We have goblet cells, which make the mucus, which again is attached in the inner layer, and the outer layer is more loose and kind of sweeps on out of the towards the back door. We have Paneth cells that secrete antimicrobial peptides, which not only get rid of bad pathogenic bacteria, but they are effectively selecting for the beneficial kind because they'll be more resistant to these antimicrobial peptides. And finally, the final layer we have is the mucosal immune system. Here we have immune cells that are sampling the contents of our intestinal lumen and the bacteria that are living in this outer mucus layer. And this is regulating our immune system in a way to make it more tolerant to things and to also look for pathogenic things that may cause a stronghold within our gut. Zooming in a little more, here we have kind of more of the structure of this epithelial layer within our gut. On the left, we have the small intestine. On the right, we have the large intestine. And as I mentioned in the previous slide, there are differences between the small intestine and the large intestine that effectively are important for the function within each. So on the left, we have the small intestine, and notice we have these peaks and valleys. The peaks are called villi, and the villi help, they do two things. They increase the absorptive area of our small intestine so that we can absorb more of our nutrients, and they also provide a kind of a distancing mechanism to prevent microbes from entering into the valleys, which are called the crypts. In the crypts, we have the stem cells and Paneth cells, which are actually making up these cells of the small or large intestine. And what happens is, as these cells multiply, they travel up the crypts into the villi and eventually are sloughed off. Notice again, in the small intestine, there is only one mucus layer. It is loose and not quite as dense, and this allows us to absorb the nutrients that are in our gut lumen. On the right, we have the colon, and here we have the outer mucus layer, which is where most of the microbes are going to be. They're having an outer mucus layer, and it's looser. Important part here is that actually provides residence for the microbiome, and that's why we have more bacteria in our large intestine than our small intestine. And our inner mucus layer within the colon is different from the small intestine in that it is dense and mostly impenetrable. So this keeps bacteria away from the cells down in the crypts, which are actually replicating to make our intestinal barrier. We have a couple of cell types we're looking at here. There are enteroendocrine cells. These are in both the small intestine and the large intestine. These secrete hormones, enteroendocrine, that regulate the digestive processes such as peristalsis and things of that nature. The goblet cells are secreting the mucus. Again, we have the stem cells that are replicating to replenish the intestinal barrier, and we also have the Paneth cells that are forming two functions. They are secreting antimicrobial mediators, the antimicrobial peptides we just mentioned, and they are actually sampling. It's interesting. They sample the presence of nutrients and they regulate the proliferation of the stem cells, which is pretty interesting. And finally, here we have a kind of a more micro view of what's going on. We can actually see the cells secreting what they secrete or doing what they do. Again, first we have the microbial barrier, which keeps out bad bacteria, provided you have enough good guys. The extracellular barrier, which is the mucus layer, or the two mucus layers, depending on where you are. The functional barrier, which is the actual cells. These regulate things like motility and secretion of enzymes, bile, and things of that nature. It's really important to point out here, most people don't think of motility as a protective factor, but it is. It prevents bacterial encroachment towards the epithelial layer, and it also prevents hyperproliferation of even good bacteria. So you don't want overgrowth. So just like a flowing river tends to not grow large amounts of bacteria, a flowing gut will tend to limit the amount of bacteria that can grow. Moving along, we have the different types of cells of the epithelial barrier, the goblet cells secreting mucus, enterocytes, and enteroendocrine cells. But we also have the tight junctions, which many people are familiar with, are what anchor the cells together so that things cannot leak in through. This is important to point out because most people, when they think of leaky gut, they just think of leaky tight junctions. But when we're actually looking at what's going on in the gut, that's the fourth layer of protection. So there are three other layers that have to break down before we even worry about the tight junctions. Again, we have the immunological barrier, the different immune cells that are sampling what's in our gut, allowing us to be tolerant to things that are beneficial and to fight off things that might enter the bloodstream and cause problems. Then we have the gut vascular barrier, which is essentially the blood vessel walls, the endothelium that kind of regulates what comes in and comes out. And finally, we have the liver barrier. At this point, you've breached the intestinal barrier, gotten into the blood. Stuff is going right to the liver, and the liver will help process anything that can become problematic. So we have 7 layers of protection here. We shouldn't just focus on the tight junctions. If you're trying to build a healthy gut, all of these things need to be healthy for you to have a healthy gut. So there you have it. It's important to understand these multiple layers of protection because they are not individual and generally tend to work with one another. For example, when you consume fiber, you bring microbes that actually thicken up the mucus layer. And in addition to that, provided you're observing good circadian rhythms, you will have a period of time where that mucus layer acts as a nutritional source to bring other microbes. Furthermore, different parts of our diet can affect this. For example, a Western diet high in processed foods can cause a thinner mucus layer, and it can also negatively impact Paneth cells, which will both affect antimicrobial peptides as well as intestinal stem cell replication. So we're going to be covering these different things. This video was simply just to give you the basics of the multiple layers of protection in the gut. I hope it served that purpose. If you have any questions, comments, or really enjoyed this, feel free to put a comment in the comment section below. Like and share on social media so that we can get this out, and I can know what you guys like so that I can create more videos. Thank you very much and have a nice day.